So this video is about solving rational inequality questions, something like number 21 in your worksheet. Okay, so I'm gonna give you a different example so that you can have variations, and the second we will solve the second time with the problem that you have in your paper. All right, so consider this example. Let's say you have this problem: x plus 1, x minus 4 over x minus 6. So your numerator is x plus 1, x minus 4. You have factored that one out. So it's important that the numerators and denominators are completely factored out. And it says this has to be less than or equal to 0. So what this basically means is that the expression on the left side should be less than or equal to 0, right? So we need to find the ranges of numbers that will satisfy that inequality. So the first thing we need to do is, assuming that the numerators and the denominators are completely factored out, is need to find the boundary numbers. And we can find them by finding the zeros of the numerator and denominator. So let's start with the numerator, which is x plus 1. That's one of the factors. We can say that is equal to 0. So, that can be equal to 0. So if you think about it, if the x plus 1 expression is 0, then everything in the numerator will be multiplied by 0. So therefore, effectively, the numerator is 0. Then remember that if the numerator is 0, then that means you can 0 divided by any number is just 0. It's still a number which is equal to 0. So that is fine. Okay. Um, the second factor for your numerator is x minus 4. That is also a numerator, so that can also be equal to 0. And then we need to also find the zeros of your denominator, which is x minus 6. Now, this is different because this is a denominator. It cannot be equal to 0. If we can, if for instance, if x equals 6, then 6 minus 6 equals 0. Remember, any number divided by 0 is undefined. So therefore, we cannot let the denominator equal to 0. So we can say that any factors in the denominator, they're not equal to 0. So now let's solve for each one. So you have x equals negative 1, x equals 4, and then x cannot be equal to positive 6. So once you get those boundaries, we will draw a number line. So this is your number line. So it's easy for you to visualize the ranges. So of course, all the way to the left is negative infinity, all the way to the right is positive infinity. Let's locate these 4 points. So we have negative 1, you have 4, and then you have 6, right? So what this means is that your number line is now divided into 4 ranges, from negative infinity to negative 1, negative 1 to 4, 4 to 6, and then 6 to positive infinity. And we want to find out which of those four, maybe which of those four will satisfy this inequality right here. Okay, so we say that negative 1 can be a value, so therefore the negative 1 right here, this is a solid dot. That means it's part of the solution. Same thing with positive 4, that's also a solid dot, but positive 6 is not. So this is going to be an open circle. So they're just boundaries. All right, so what we need to do now is we will pick a sample number within the ranges. So for instance, from negative infinity to negative 1, we can pick negative 5, right? Okay, so because that's a number. So this negative 5 is representative of all numbers between negative infinity to 1. So if we substitute negative 5, so think about negative 5 here, negative 5 here, and then negative 5 here. Okay, you don't really need to find the actual value. You just need to find out if it's positive or negative. So negative 5 plus 1, that's going to be a negative 4. So that's going to be a negative number times negative 5 minus 4. That's also going to be a negative number over negative 5 divided by negative 6 is also going to be a negative number. So what will happen when you multiply negative times negative? Okay, that's going to be positive divided by negative. So therefore, all of these is going to be a negative number. So that means any value from negative infinity to negative 1, they will always give you a value that is a negative expression. Okay. All right, so that's for negative infinity to negative 1. Now let's try a number between negative 1 and 4. So let's try 0. So plug in 0 here, 0 here, 0 here, 0 plus 1, that's going to be a positive number. 0 minus 4, that's going to be a negative number. Divided by 0 minus 6 is also a negative number. Okay, so positive times negative is negative, divided by negative, that's going to be a positive number. So everything in this area is going to be a positive number. Everything in this area right here is going to be a negative number. Okay, Next one, between 4 and 6, let's try 5. So if you do 5, so 5 here, 5 here, 5 here, 5 plus 1, it's going to be a positive number. 5 minus 4, also a positive number. And then 5 minus 6 is a negative number. So therefore, positive times positive divided by negative is going to be a negative number. So anything between 4 and 6 is going to be a negative answer. All right, next one, between 6 to infinity, let's try 7. So 7 plus 1, it's a positive number. 7 minus 4 is also a positive number. 7 minus 1 is also a positive number. So positive times positive divided by positive, that's going to be a positive number. Okay, so now that you have done all of those, we need to find, so how do we know which one is the answer? Well, this is the one that will tell you, because it says this solution here should be less than or equal to 0. So that means they have to be negative or equal to 0. So let's choose which ones are going to give you 0. So we have this and we have that. So those are the ranges that will be the answer to this problem. So that will be from negative infinity to negative 1. But negative 1 is is a solid circle, so therefore that will be a bracket. So that's good. And then this one also from 4 to 6. 4 is bracket, but 6 is open circle. And they have you need to put a U, so it's a union. So you have two ranges where the ranges from numbers negative infinity to 1 will create a negative value for this. Same thing as 4 to 6 also create a positive value for that. Okay. Now, say for instance, there is no equal sign here, then all of these will be open circles, right? Okay. So that's for that example. Now let's try the example, the actual problem that you have. So you can try that if you want. You can try it first before you look at my solution, or vice versa. It's up to you. Okay, so you have 3x plus 2 over x minus 1 is greater than or equal to 2. So what we need to do is to make sure that the expression on the right side is 0. So therefore, we need to subtract 0. 0 is just easy to work with because, anything above 0 is positive, anything below is negative, and everything equal is just 0, right? So now we have 3x plus 2 minus x minus 1 minus 2, that's 2 over 1 essentially, is greater than or equal to 0, right? Okay, so now we want to combine them because now you have two terms, so therefore we need to multiply this by x minus 1 because that's your greatest least common multiple, right? So now we can rewrite this as x minus 1, 3x plus 2, nothing will change, minus 2 times x minus 1 over x minus 1. Okay, so now let's combine them into one term. So you have a one denominator, so that's x minus 1. The first one will be just 3x plus 2. But the second one, you need to distribute the negative 2. So you have minus 2x plus 2, and all of these should be greater than or equal to 0. Now simplifying the numerator, 3x minus 2x is just x. So you have x plus 4 over x minus 1. Okay, and all of that should be greater than or equal to 0. So now that you have a simplified, because you cannot really factor the numerator anymore, you cannot factor the denominator anymore, so therefore those must be the factored forms. So now let's find our boundaries. So we can say that x plus 4 can be equal to 0 because that's a numerator. However, x minus 1 cannot be equal to 0 because it's a denominator. So therefore, x equals 4, and then x is cannot be equal to positive 1. Okay, so now that you have your boundaries, okay, now remember there is an equal sign here. Okay, so now that you have your boundaries, let's look for our number line. So this is negative infinity, positive infinity. Let's locate our points. This one should be negative 4. So now this is negative 4, and then you have 1, right? Okay, so now you have 4. Negative 4 can be a solution, so therefore this is a solid dot. Positive 1 is not, so this is an open circle. All right. Now again, if there's no equal sign here, this 4 should just be an open circle. Okay. So let's pick some sample values between negative infinity and negative 4. We can choose negative 5. So if this is negative 5, this is negative 5. Negative 5 plus 4 is negative 1. Negative 5 minus 1 is negative as well. So that will give you a positive answer for this area. Now, for the second one, negative 4 to 1, let's choose maybe 0. You can choose any number as long as it's between negative 4 and 1. Make it easy for yourself. All right, so 0 plus 4 is positive, divide by 0 minus 1 is negative. So all of these will be negative answers. From 1 to positive infinity, let's try 2. If that is 2, then 2 plus 4 is going to be a positive. 2 minus 1 is also positive. Therefore, this is going to be a positive. So how do we decide which one is the correct answer? Well, it says here it has to be greater than or equal to 0. The greater than is the one that will really tell you. Okay, the equal sign here tells you if these solid dots are actually open circles. Okay, so right now we need to choose the ones that are positive because it has to be greater than 0. So we want this and we want that. So therefore your answer for this will be from negative infinity to negative 4, bracket here, parenthesis here, union 1, open parenthesis because that's an open circle, comma, positive infinity, open parenthesis. So this is the solution to your problem here. Okay, so let me know if there's anything that you want to ask. I'm just a message away.